Dear students, I am Pardeep Koul, lecturer in chemistry. So we will continue with the surface chemistry. In surface chemistry, we were discussing solutions. Now we have various types of solutions which we have studied in detail. Three types of solutions on the basis of particle size. For example, we have true solutions, then we have suspensions, then we have colloids. Depending upon the particle size of these solutions, we have classified solutions into three classes. True solutions, we have already studied them in detail. Similarly, we have studied suspensions in detail, and we have discussed even colloidal solutions in detail. Today, we will discuss some properties of colloidal solutions. So, let us discuss some properties which owe to the colloidal solutions. So, first property today that I am taking for colloidal solutions, that our colloidal solutions, their particle size, the particle size of colloidal solutions or colloidal sol, we can call them as, is between 10 raised to power minus 9 to 10 raised to power minus 6 meter. So those solutions where particle size ranges between these two parameters, 10 raised to power minus 9 to 10 raised to power minus 6 meter, such solutions are known as colloidal solutions or colloidal sols. In these solutions, that is in colloidal solutions, if we have only two components, suppose we have two components in a colloidal solution, such a colloidal solution will be known as a binary colloidal solution. Now, in a binary this colloidal solution, we have two components. One component that is taken in larger quantity, that is called dispersion medium, and the other component which is taken in smaller quantity, which is present in smaller quantity in that colloidal solution, that is known as dispersed phase. So we have two components in a binary colloidal solution. In a binary colloidal solution, binary means which has two components. In a binary colloidal solution, the larger component is called dispersion medium, while the smaller component is called dispersed phase. So we have two components in a colloidal solution known as dispersion medium and dispersed phase. Then if we keep a colloidal solution for some time in a container, let us see what happens to it, whether its particles settle down or they don't settle down. So I mean to say their stability. So our colloidal solutions basically do not settle down. Their particles do not settle down. So we can say that they are very stable. Colloidal solutions are stable in nature. Colloidal solutions are stable in nature. They don't settle down. on keeping. When we keep them, their particles do not settle down. In other words, we can say that they don't show sedimentation. They don't show sedimentation. By sedimentation we mean that is they do not settle down. However, there are a few exceptions. There are some colloidal solutions which may settle down but very slowly. Their sedimentation process is very slow, almost negligible sedimentation. Then coming to another property of these colloidal solutions, if a colloidal solution is passed through a filter paper, now the question is whether it can pass through the filter paper or not. It all depends upon the particle size of this solution. Since the particle size of colloidal solution ranges between 10 raised to power minus 9 to 10 raised to power minus 6 centimeter, these solutions can easily pass through a filter paper. Why? Because the pores of filter paper, their size is bigger than this size, than the particle size of the solution. So the colloidal solutions can pass through a filter paper. Why? Because due to their smaller particle size. So due to their smaller particle size, the colloidal particles can pass through a filter paper. So this property of colloidal solution is known as filtrability. So our colloidal solutions show the phenomenon of filtrability. Now we have another property, that is colligative property. There are some properties of solutions which are known as colligative, and colligative properties are those which fully depend on the number of solute particles and not on the here solute means dispersed phase. Depending upon dispersed phase, the property is known as colligative, which fully depends upon the dispersed phase. So as far as this property, that is colligative property of these solutions is concerned, our colloidal solutions, they show these properties. They show colligative properties, but low. They show low colligative properties. They show low colligative properties, like there are some colligative properties like osmotic pressure, vapor pressure, etc. These are some colligative properties. So our colloidal solutions, they show these colligative properties. Coming to another property, that is Brownian moment. Brownian. The colloidal particles always remain in motion. They show movement, and their movement is continuously in zigzag path. If this is a colloidal solution, their motion is like this, zigzag. And this type of motion was first of all discovered by a scientist whose name was Robert Brown. Robert Brown said that colloidal solution particles, they always remain in motion, and their motion is in zigzag paths, and this motion was referred to as Brownian movement after the name of the scientist who discovered this movement. He discovered this movement in 1827. So our colloidal solutions show Brownian moment. That is, what do you mean by Brownian moment? Zigzag motion of colloidal particles. This motion was first of all discovered by Robert Brown in 1827. That is why this moment is known as Brownian moment. Then we have another property, that is Tyndall effect. Let us understand this effect first. Suppose I have a source of light here. Suppose this is a source of light, and this is a lens here, a convex lens. Here I have a solution, true solution. I have kept a true solution in this container. This is a true solution. Then here I have a colloidal solution here. This is a true solution. This is a colloidal solution. Now a beam of light, after passing through this lens, falls on the true solution. This is a true solution kept in a glass vessel. This is a glass vessel, so that light should pass through it. So when light passes through it, it passes through it and without being visible. We can't see that light is passing through this solution. So true solution do not show this effect, Tyndall effect, because when a beam of light is passed through it, its path is not visible. However, that light passes through the true solution, but that light does not scatter, that is not visible. But when the same beam of light is allowed to pass through the colloidal solution, what happens? This path is visible. This is visible path. We can quite clearly see the path of the light, and this effect is known as Tyndall effect. Now, true solutions do not show Tyndall effect, while as our colloidal solutions show the Tyndall effect. Now coming to another property, that is electrical property. Now our colloidal solutions, they show electrical property. What we mean by showing electrical property? It means that our colloidal particles are charged. I just discussed with you that a colloidal solution has two components, that is dispersion medium and dispersed phase. Dispersion dp dm, dispersion medium, and dispersed phase. As far as dispersion medium is concerned, it has got no charge at all. But our dispersed phase has either positive charge or negative charge. So depending upon the charge of dp, there are positive these colloidal solutions and negative these colloidal solutions. So we have positive colloidal solutions and negative colloidal solutions as well. For example, we have positive these colloidal solution like iron hydroxide. Then I have calcium hydroxide. This is ferric hydroxide or iron hydroxide. This is calcium hydroxide. This is aluminum oxide hydrated, X times of water molecules. This is hydrated aluminum oxide. These are positive colloids because in these colloids the dispersed phase has positive charge. Similarly, we have negatively charged colloids also, like solutions of salts of copper, silver, platinum, gold. The solutions of these metals, these are all metals, are negatively charged colloids. Similarly, we have cadmium sulfide, we have arsenous sulfide. These are also negatively charged colloids. So I have one more negatively charged colloid, that is Congo. Congo is basically a red dye. This is also a negatively charged colloidal. So these are some properties of colloidal solution, and it is all for today. That is all. Thank you very much.